Without further ado, I like to buckle up and let us navigate and understand how we can suss out these details using some simple use cases with Ocular. And note that you can even go into advanced use cases as well. But for sake of this webinar, I will illustrate a few simple use cases. To guide our next few use case using Ocular, I'm going to use a project that is open source. It's essentially available at this moniker, which is github.com/conneqc.tarpit. This project is fraught with vulnerabilities and business logic flaws and is available for anyone to navigate with once you get started with the trial of Ocular. What I will do quickly is shift into my console to guide the next few steps. Like I mentioned, I will be using this project called as Tarpit, which is available on GitHub. I'm going to quickly switch to my console. The first step that I've done is clone this project and essentially build to create an artifact. Given that this is a Java project which is deployed on a Tomcat servlet, what I've effectively done is created a web archive as a consequence of building or initiating a Maven build. Ocular is a command line interactive tool that takes as input a particular proprietary format called as code property graph, which essentially is a graphical representation of your code. This graph essentially encompasses the custom code that you write, the open source it consumes, and the framework upon which it is deployed. Think of it as a graph of graphs. Having this graph enables us to effectively understand information flow and thereafter ask interesting questions to see if there's certain business logic flaws that can be triggered on these information flows. So as a next step, I'm going to create this graph that I just spoke of. Typically, it takes less than 10 minutes to create a graph in association to an application being analyzed containing over or approximately 500,000 lines of code. But if you're writing very tiny microservices, which is very optimal and the typical modus operandi these days, it takes less than a minute or perhaps less than 2 to 5 minutes to create this graph. Note that it took literally less than 10 to 15 seconds to create this graph because my application that I'm demonstrating today is fairly simple. Ocular is a command line tool, and what I'm effectively going to demonstrate today at this moment is using Ocular in investigative mode. But you can expand the scope and use Ocular in an autonomous mode as well, meaning take your insights, create scripts and recipes, and bolt it into your continuous CI/CD pipeline so that these evaluations are conducted constantly on a release-per-release basis. So on starting up Ocular, now I effectively have the ability to ask questions over this graph. But before doing that, I'm effectively going to load a set of recipes that I often use. And by the way, we provide you a set of recipes, batteries included, which essentially contains different patterns of business logic flaws, backdoors and rootkits, and common vulnerabilities. So right off the bat, you get value without even writing a single line of code pertaining to your recipes. The language used by Ocular for interaction is a meta language, which is essentially based on Scala. So if you're familiar with Java or Scala, it feels very native as you interact with Ocular. The first step that I'm going to conduct is load that particular graph that we spoke of or just created at the moment. As this graph is loaded, it enables us to ask interesting questions over this graph. And just to quickly demonstrate, I'm going to execute a particular command which enables me to get all hard-coded literals in the code. Now, this is just a simple command, but it has very high value because I can go one step further and ask if the engineer has mistakenly hard-coded any credentials like AWS secrets, AWS tokens, GitHub access tokens, etc. The other interesting value that can derive of Ocular is you can identify your software composition encompassed in your application as well. Now, Ocular just does not give you version-dependent pairs. It can also go one step further in letting you know whether you're using any vulnerable open source library in an unsafe way. So this greatly helps in prioritizing what needs to be addressed from an open source software composition analysis standpoint. But what I'd like to do now is quickly give you a glimpse of the first use case that we're going to traverse.